Okay, twice I've tried to make a video about 3.18, or I have, and twice I got this weird error message. Well, hey, maybe I can do it more slick or smoothly. Um, so this question right here and many other things we're going to do, they're based on Theorem 3.1 and Lemma 3.7. So while I'm erasing this, go look those up and I'll read them over. That's problem 3.18b right there, and I'll get back to that. But first, what I want to do is I want to illustrate what is going on with this and this, in particular Lemma 3.7, which is actually quite important and cannot just be overlooked or glossed over. You need to understand what it says. I mean, in words, what it says is that the solution set for any system of equations is given by the solution set of the associated homogeneous system, all added to any particular solution. Well, that's a lot of words, and it's true. But I want you to see what it means geometrically. Now, I did state this before, but I think I should draw some nice pictures to go along with it. So let's start off with let's just use a really simple example. Let's suppose that we have trying to dry the board off here. Let's say we have a 2x plus y equals 6. Now that's one equation and two unknowns, and we know what the solution looks like. It's going to be a straight line, right? So there'll be infinite. Oh, here, I'll draw it. Y-intercept is 6. 1, 2, 3, 4, 5, 6. X-intercept 3. So it looks like this. This is the solution. What do I mean this is a solution? What it means is any point on this line, a point is an ordered pair, any point on this line is a solution for this. So this equation generates this line, and this line represents the solution set of this equation. Nothing shocking there. What have we been doing as of late? We've been solving this with Gaussian elimination, so let's do that. Well, it's already in echelon form. Great. What's the free variable? Y. Y equals y. Solve for x. X would equal negative 1/2 y plus 3. And then we write this, what we've been doing is we've been writing this as a sum of a specific particular solution, specific or particular, and a linear combination of all the free variables. So in this case here, we can use any specific solution we want, but the easy one to use is where y is 0. If y is 0, that makes x 3 plus something times y. That has to be 1, because 1 times y is y, and we want y to be y. What would go here? Negative 1/2. We could write this in set builder notation, but that won't add anything to the problem right now, so we'll just leave it like this. Now, here's what Lemma 3.7 says. It says, not necessarily instead, but you can do the following. You can write down the associated homogeneous system, 2x plus 7 equals 0. Let's solve plus 7 plus y equals 0. Let's solve this. It's already in echelon form. Y is the free variable, so y equals y. What does it make x equal? Negative 1/2 y. What's the particular solution? If you make y 0, x is 0. That's the 0 vector. If you add the 0 vector to anything, it doesn't change anything. So nobody usually writes it down. Instead, we'll say the solution is this. Something times y, and we want y to be y and x to be negative 1/2. Notice how this term and this term both appear, and there's a way to look at that. What does that represent over in the picture? Well, this is a vector, negative 1/2, 1. So come over here, negative 1/2 and up 1. That's, if you will, that's this vector right here. This is the vector that gives you the direction of the solution space. The solution space is a one-dimensional subspace of the host space, which is two-dimensional. What does this do? What is this vector right here? This is the vector 3, 0. 1, 2, 3, 0. That didn't have to be this way. That was on the x-axis. But at any rate, this vector tells you where to place the line generated by this combination. What Lemma 3.7 says is we can do the following. We can take any point which is a solution to the original system. You choose. Let me choose one. I'll just choose one that's, not too crazy. Let's go over here to 5. If x is 5, let's see. If x is 5, where are we at? Right here. Y is -4. So this right here is the point 5, comma, -4. And I can represent it as a vector or as an ordered pair. It's the same thing. Now, what Lemma 3.7 says is we can do the following. We can add that here. 5 is the x-coordinate, y is -4. And if we consider all vectors generated by this expression, using all real numbers for y, that would generate that line over there. Well, that makes sense because what we're doing is we're taking the same line generated by this red arrow and we're shifting it over here, but that would be the same line whether or not we had shifted it here or here. So it seems reasonable. The book offers a proof. It's correct. I don't have a better one, but it's fairly detailed and rigorous, and you can read through it. It's quite long, right? What I want to do is give what's called a plausibility argument. I just want to show you that this makes sense. You go, okay, yeah, that seems pretty reasonable. Now, how would one do that? Well, the first thing you might do is to pick any point on this line and see that this point can be constructed using this expression. To prove it, you would have to say that that's true for all points. I'm just going to pick one. So let me pick one here. How about x is -2? If x is -2, y is 10. So let's see if this can actually be done. Now, there's a bit of a subtle maneuver we have to make here. When I write this here like this, as this expression via Lemma 3.7, this no longer represents the y coordinate. This represents any constant. So to avoid confusion, I'm going to put a c there. C is a real number, it's a constant. And what theorem 3.7 guarantees to us, or claims to guarantee, is that, let's go ahead and write this out. We'd have 5 minus c for the x. That should equal -2. And -4, oh geez, look, plus 1/2 c. Minus, 1/2 c. And then -4 plus c should equal 10. Lemma 3.7 guarantees that there will be a value of c such that these are both true. So let's see if that is in fact true. Let's see from the first equation here. Let's go ahead and solve for c. We could subtract 5 from both sides and get -7 and multiply both sides by -2. So c would equal 14. Put 14 in there, and lo and behold, yes, it checks out. Okay, now I'm going to end this video now and continue in the next video to do 3.18, and here's why. Because I don't know if my videos are running too long, and that's why I was getting these error messages. My last video, I think, was 26 minutes for the whole thing. Done it twice. Both times I get a message that said, oops, we disconnected you. I don't know what the heck's going on. So out of a fear of doing it a third time, and who knows what the emotional ramifications would be for me, I'm going to hit finish, and then we'll actually finish it on the next video.